Welcome back, friends, to Skill Raptor. I am your host Atharva, and today also we are going to see a very exciting topic, that is calculation of a wall coefficient. So before I move ahead, first of all, I want to request you to like, share, and subscribe to my channel. In our last lecture, when I promised that we will be distributing free sheets for heat exchanger design calculation, we have already done that. So I hope you like that. But I want to request you all that since this such videos takes a lot of time to make it, and to plan for a video and to shoot it, it really is kind of a work for me. So but as compared to that, I'm not getting much of subscribes and likes, so I would really request you to all to like, share, and subscribe, and also press on the bell button. The reason is whenever we share such a video where I am sharing free sheets or something like that, that link is for limited time. So if you miss on the bell icon button and if you don't get a notification at the right time, you may miss on to a very important Excel sheet. Okay, so with that, I want to start with today's lecture. So today we are going to see how to calculate a wall coefficient, that is when a liquid flows through a wall, say a globe wall. If you know a pressure drop across the walls, if you know the flow rate and the properties of the liquid, so how you can calculate the CV, that is a wall coefficient, or coefficient of for walls, you can say. And also, I would like you to watch this video till end, because I will also be showing you a trick in the Excel sheet, which I will be showing you in short time. Here, if you know the CV, that is a coefficient, then how you can actually back calculate the flow through the wall, that we are going to see. So we are on the Excel sheet. What we want to discuss, so we will be calculating wall CV, that is coefficient of wall, that is generally used to size a wall, or you can say to analyze the efficiency of a wall. So what exactly a CV is? So CV is it's an estimate of a wall, which says how much amount of liquid will pass through a wall given a unit pressure difference, that is in psi, say 1 psi, for a given temperature, that is around taken given as 60 Fahrenheit. So it's a wall sizing kind of a calculation, you can say. Now you will see on the interface, there are green boxes, yellow boxes, and red boxes. So red boxes are actually the one which gets calculated. Green boxes are the inputs which we want to give, and yellow is our actually objective, what we want, what we are here for, that is CV for required flow. But if you are given a CV, say for example, if you select a valve, say you select a globe valve or a ball valve, and if you know the CV of that, say this value you know, that is 24.6. So how can you calculate the flow through the valve, say 15 here? So the reverse calculation is also possible in this sheet, which I am going to discuss in towards the end, that is in couple of minutes. So please watch this video till then, like, share, and subscribe. So now let me show you how this sheet works. So in the first column you have calculation of a wall CV, then value. Under value you have water, which is a liquid name, so you can actually change the liquid names as per your desire. Then density of the liquid, which you will have to put up. Viscosity, here viscosity of liquid is 1 because we are taking water. Then vapor pressure of valve inlet condition, this you should know. Critical pressure of the liquid, this is generally known, it is in bar absolute pressure, and this is for use for only laminar flow, you need to understand this. Also, just to give a disclaimer, this is for educational purpose, and one should always consult a good reputed supplier for detailed designs. Okay, with that in mind, let me just move to the next section, that is wall type. So globe wall, now wall critical coefficient, this is zero point 0.8 we have taken, so zero point 0.9 is taken as default, and you can also check the tab down, this is CF, you can see the tab below liquid service, that this is that CF. So in CF tab I have given the standards which are generally taken. So CF for globe wall is 0.85 when it is a normal plug, and for reduced plug it is 0.80. Then there are butterfly wall and ball wall values. So if you are using any wall out of this which are generals. So these are general walls which generally are used. So you can use this. So now I am switching the main. So these are the values which you want to put now, and pressure upstream the wall, that is 6.5, downstream the wall 6. These are the measured ones because these are the inputs. You can see it is in green. So these are the things which you should actually know if you want to calculate a CV. Now say I actually want to show how it works. So say now my wall critical coefficient is 0.8, but I want a flow through the wall, say 20. I am just changing for to show you, and just press enter, and you can see the values have actually changed and downside, and it actually shows. Also there is one more feature. So the regulation is given, it is 65%. So enter here the percent at which you wish to wall regulate for the flow, entered in C19. So C19 is nothing but flow type, which is a subcritical flow. And say if you want to regulate a flow to 65% or say 70%, and you just change. So you can see the values have changed. So flow type is what will get calculated, then mass flow is getting calculated, then pressure drop is getting calculated, and majorly CV for required. So 32.8 will be the CV, that is coefficient of wall. The volume coefficient also sometimes we call it, that's why it is given CV. Now say if you purchase a wall and you have this value already, so CV for required flow, you know, and now you want to calculate if this is my wall and these are the setup, how much flow will be actually encountered by the valve, how much will actually pass through it. So for that there is a trick here. You just watch this video till end. So just click on C20, then go to the data tab. In data tab, go to what if analysis on the top side, and in top side what if analysis, go to goal seek. Just click on the goal seek, and you will see set cell. So C20 is what I have clicked to value. Say now you purchased a valve which is a globe valve, and it has got a CV which is given by the manufacturer of say 45. Just type 45. Then by changing the cell, so we want to find the flow through the wall. So I'm just clicking on C12 because this is what we want to calculate now. So I'm just back calculating things. Just press OK, and you will see the values are being calculated. So flow through valve. So this much for a 45 CV, you will have a flow of 47.4 meter cube per hour. So this is the sheet overall, and you can use it very easily. You can also enter turbulent or laminar. Say I enter a laminar flow here. Just press enter and see the values have changed. I will just push it back to turbulent. So and also linear type of valve. If you have a equal percentage of valve, so you can just write a equal percentage. Just press enter, and you'll see the values will change accordingly. So this is a very good workable sheet which can be used for calculation of volume coefficient for walls. This can be helpful for industries also to take a ballpark number, or you can check your wall. It's very easy to calculate. And so here I will just stop my small lecture. And by the way, this sheet I will be sharing with every one of you. But please kindly like, share, and subscribe. We are currently 144 of us. There are 144 subscribers right now, and I want to grow this family. And I please request, let us cross 200. Let's put a target of 200 before we share the next sheet. So thank you very much.